Hello everybody, welcome back to Ram Circuit class. Today we shall be discussing one more important topic, that is the how electrons are drifted from one to other end of the conductor when we switch on the light or battery is connected. Okay, so that word simply is known as drift velocity of electrons. So how the electrons are sent from one to other end by the help of a battery or a power supply and whatever else resource we have, we shall be drawing expression for the drift velocity of electrons. So without wasting our time, just get started on the topic. Consider we have a conductor and this is having a large number of free electrons. In the last video, we had discussed the average thermal velocity of all electrons inside a conductor is always 0. If you have gone through that lecture, the average thermal velocity of all electron is always 0. That is, all electrons keep on moving randomly in different direction. This is going this way, this going this way, this going that way, and so on. So all electrons are moving randomly without any particular choice of direction. So now the case is a little more different. We are applying a cell of potential V. The length of the conductor is L. Okay. So what happens? Okay. This plus and minus terminals will produce an electric field E, and that is directing from plus to negative direction of the conductor. So we know that the conductor contains a large number of electrons, and these electrons can freely move well inside the volume without leaving the volume itself. But one condition is there: the electrons will suffer collisions with the next or other electrons, and simultaneously they collide with the ions of the conductor which have left or which are now free of electrons. So electrons will collide two types of body. First is electrons and the second is what? The ions. So what happens? As we know that the general velocity of all electrons, the average velocity of all electrons, that is thermal average velocity, is u1 plus u2 u3 up to un is always equal to 0. This is the expression for the average thermal velocity. Now what happens? Suppose this is an electron, these are the electrons. These electrons will be moving towards the, or we can say these electrons have a tendency now to move from the negative end to the positive end. Whatever restrictions are there, whatever resistance is there, whatever collisions are there, finally the electrons will like or love, or they will be compelled, they will be forced to move from this end to that end, and this process simply makes the electric current flow through the particular conductor. So however, what happens? After all, at the end of every fight of electrons with other electrons or the ions, positive ions, the electrons simply reach from this to that end, and that is constituting what? Electric current, because current is what? The flow of electric charges. Okay. That's very clear to you all. Now what happens? This electron, while going to this direction, suppose it is colliding with a big ion, it gets reflected this way. Here it is again collided with one more electron, so this electron is reflected back or simply deflected in this direction. So this is the, again it meets a big positive ion, so that is again reflecting it in backward direction. So however, this electric field will exert a force on each and every electron. So what is that force is equal to? We know that force on a single electron is given by E into E. If we use the charge with direction, it means the force will be opposite to the direction of the applied electric field. Electric field goes this way and force will be this way, because electrons are what? Negatively charged particles. So if m is the mass of electron, due to this force electrons will be accelerated for the next collision. So acceleration is given by Newton's second law, force over mass, that is minus E, capital E over m. Here I would like to remove the sign negative, because that is already making a sense that electrons are moving in this direction. So we will talk only the quantity of the force or acceleration. Hope you must be getting what I mean to say is. So due to this acceleration, every electron initially moving with some, suppose we are talking about the first electron. The electron was initially moving with u1. It is now accelerated by this acceleration. So it will acquire, suppose this electron is coming after suffering through large number of collisions. Now it is here and it is moving with velocity u1, and simultaneously an acceleration acts on this electron. So it will move towards another electron before collision. Suppose this electron takes a time tau 1 in reaching to this distance. Mind it, this electron has not suffered any collision till now, that is up till of this time interval t1. So if initial velocity was u1 and after time t, what will be its velocity? So its velocity is given by what? Initial velocity plus acceleration and that time 1. Mind it, this is common acceleration for every electrons. This is the initial velocity of first electron and this is the time interval, the time duration during which the body has covered this much of distance, and maybe it is going to just strike the next one but has not yet stuck the other electron or even ion. So this is the velocity acquired by the first electron after time this. Similarly, for other electrons, we have similar expressions, that is u2 plus a tau 2 and so on. We get the velocity of nth electron, that is initial velocity tau n. Clear? This should be very clear, unless we cannot move ahead. So this is the velocity of acquired by every electron before their next collision and given by this Newton's first equation of motion. So on an average, now going to calculate on an average what is the average velocity of these all velocities. So the average of all velocities, that is say v, is equal to sum of all the velocities and that is divided by number of electrons. So putting their values, we have u1 plus a tau 1 plus u2 plus a tau 2 so on un plus a tau n. Please mind it that acceleration will be common for all electrons, only u and tau will be different. This. So collecting first u1, u2, u3, u1, u2, u3 plus a is common, this is tau 1 plus tau 2 plus tau 3 and so on. I can put this n twice if you are very clear in mathematics. Hopefully this is not creating a problem for you. So guys, this is what the thermal velocity is average, and as per this equation this u has to be 0 and we are only left with this equation. So what next is, that is v, that is average velocity, or I must write average here. V average equal to 0 plus a, and average of all these tau is denoted by single tau, that is V average equal to a into tau, where tau is the average value of all this single tau 1, tau 2, tau 3. These are the time interval in which the body has travelled certain distance before the next collision for each and every electron, mind it. So this is the average electron velocity. So a is equal to what? Small e, capital E over mass of electron, as we discussed earlier, and this is the tau. And this average velocity of all the electrons is known as the drift velocity of electron, and this is finally denoted by V and subscript d. That is the drift velocity V d is equal to small e, capital E over m multiplied by tau, and this is tau is called relaxation time, and this is given by this. Now if I use the vector notation, that is v, and here we introduce a minus sign, this minus sign, negative sign, introducing and showing what? The drift velocity of electrons will be in opposite direction to that of the electric field set up by this cell inside the conductor. Okay, because say this, the electric field is from plus to negative direction, and all electrons have a final tendency to move from negative end to the positive end. So why this minus sign is for. Okay, so please note down all the steps carefully. This is a very important expression for us. Okay, carry on guys.